Okay, so let's do another example. Let's do 2 cosine 4x plus pi over 6 minus 1 equals 0. Okay, so if we follow along with what we did yesterday, our strategy would be to solve for the trig function. So in this case, that means adding 1 to the other side. And then dividing by 2. Now at this point we apply one of our rules. Okay, keep in mind that this entire thing we're thinking of as theta, right? And so the rule for cosine was if cosine theta equals k, then theta equals cosine inverse of k, or theta equals 2 pi minus cosine inverse of k. So in this case, I'm going to say, okay, instead of theta, I'm going to do 4x plus pi over 6. I'm going to say, all right, so 4x plus pi over 6 equals cosine inverse of 1/2 plus 2n pi, or 4x plus pi over 6 equals 2 pi minus cosine inverse of 1/2 plus 2n pi. Okay, so now, well, first of all, we can figure out what cosine inverse of 1/2 is, right? So cosine inverse of 1/2, we should be dealing with pi over 3, right? So we've got 4x plus pi over 6 equals pi over 3 plus 2n pi, or 4x plus pi over 6 equals, well, 2 pi minus pi over 3. Let's think. So 2 pi would be 6 pi over 3. 6 pi over 3 minus pi over 3 would give us 5 pi over 3 plus 2n pi. Okay, now of course we're not quite done. Our goal is to solve for x. So we need to subtract pi over 6. Pi over 3 minus pi over 6 would be, well, pi over 3 is 2 pi over 6, right? So we have 2 pi over 6 minus pi over 6. That should be pi over 6. We don't have to subtract pi over 6 from 2n pi, right? Because if we've done the subtraction here, then we're done subtracting, and they're not like terms anyway. Okay, but now at this step we would divide by 4, so we would say x equals pi over 24 plus, well, 2 divided by 4 is 1/2, so I'm going to say n pi over 2. We do a similar thing over here, right? Subtract pi over 6. 5 pi over 3 is 10 pi over 6. 10 pi over 6 minus pi over 6 would be 9 pi over 6. Oh goodness, 9 pi over 6 reduces, right? That would be 3 pi over 2. So we're going to get 3 pi over 2. Okay, plus 2n pi. If you didn't catch all that, pause the video, rewind it, listen to me go through that again. Of course, you could also use your calculator and do 5 pi over 3 minus pi over 6. You should get 3 pi over 2. Okay, then we divide through by 4 again. We're going to get x equals 3 pi over 8 plus n pi over 2. So if you want to know all of the solutions to the equation, well, you would say all of the solutions are of the form pi over 24 plus n pi over 2, or 3 pi over 8 plus n pi over 2, where n is an integer. If you just want to generate a list of solutions that live in the interval 0 to 2 pi, Well, then you take turns plugging in numbers for n, and you only keep the ones that live between 0 and 2 pi. If I were to plug in -1 for n, for example, I'd have pi over 24 minus pi over 2. That would be less than 0, so I'm not going to keep that solution. But if I plug in 0 for n, I get pi over 24. Okay, that's in there. If I plug in 1 for n, I get pi over 24 plus pi over 2. That's 13 pi over 24. If I plug in 2 for n, I get 25 pi over 24. If I plug in 3 for n, I get 37 pi over 24. When should I stop? I should stop when I surpass 2 pi. That would be 48 pi over 24. So I should stop when I surpass 48 pi. Let's see. If I plug in 4 for n, I get 49 pi over 24. That's too far. Okay, so I should stop. Okay, so those are I get 4 solutions generated from this first rule. Okay, I suspect I'm going to get 4 more generated from the second rule. Let's see. So if I plug in -1, I'm going to get something less than 0. If I plug in 0, I get 3 pi over 8. If I plug in 1, I get 3 pi over 8 plus pi over 2. That's 7 pi over 8. If I plug in 2, I get 11 pi over 8. If I plug in 3, I get 15 pi over 8. And I think I stopped there. I shouldn't surpass 2 pi, so I shouldn't surpass 16 pi over 8, right? 16 pi over 8. And so I have a feeling if I add another pi over 2, I'm going to go over my limit. So that's my solution set there, right? So those are the solutions that live between 0 and 2 pi. Okay, so that's that one.